Biodiversity is a term that represents the total variety of all life on Earth. That's a big thing to sum up. Thousands of different wild habitats, millions of different species, billions of different individuals, and the trillions of different characteristics they all have. The total biodiversity of our planet is immense, which is a good thing, because the more biodiversity, the more secure all life on Earth is, including ourselves. Only when life is at its most varied, vigorous, biodiverse, can we hope to thrive. We may not know it, but we need towering forests across 1/3 of the land surface to lock away carbon and keep the climate stable. We need millions of pollinators and billions of soil organisms and megatons of plankton to keep the food we eat in supply. We need strange plants deep in jungles to create our medicines, and coral reefs and mangrove swamps to protect the coasts we depend upon. Our planet's biodiversity provides all the things we need for free. But it will only do so if there's lots of it, and at the moment it's under attack. In the last 50 years, our activities have dramatically reduced biodiversity across the globe. We've snuffed out habitats, reduced populations of wild animals by 60%, and even driven whole species extinct. The number of lions in Africa has dropped by 65%. The number of individual flying insects in Europe has dropped by 75%. The number of bluefin tuna in the Pacific has dropped by 95%. Biodiversity is dropping everywhere and fast. This is catastrophic for nature and therefore ourselves. We talk about climate change a lot, but biodiversity loss is as important an issue. How do we stop this loss of life? How do we ensure that biodiversity, our planet's vital statistic, begins to increase again? In fact, we already know exactly what to do.
Let's talk about some of the factors that contribute to the uneven distributions of life on Earth. Why do different organisms have different ranges and different distributions? First, let's imagine the planet without humans. What factors would govern where you find different kinds of life on Earth without our influence? In such a world, life would still exhibit distinct distribution patterns, distinct ranges, and different overlapping ranges. The ranges of some species are large, some are small, but the key here is that the distributions would in fact clump. There are some places on Earth where the distributions overlap in larger numbers than in other places. And this is because every species has its own preferred place to live, and sometimes the preferences overlap, more in some places than in others. Now, it doesn't mean the species are thinking about it and saying, Hawaii's nice this time of year, but it does mean that every species tends to have a characteristic range. There's a set of conditions in that range that allows the organism to get its food, to reproduce, and do all the things that members of a given species have to do to survive in their habitat. Preferences are determined by three main factors: physical, biotic, and evolutionary. Let's have a look at each of these. Physical or environmental factors are things like the geography of the place. Is it fresh water or salt water? Does the organism prefer living up in the air or underwater? Does it prefer living in mountains, in deserts, flatlands, or in caves? Physical factors also include things like climate. Temperature and rainfall are two of the things that drive the distributions of organisms. They can govern where certain life forms can live. If we look more closely at temperature, it's not only whether it's hot or cold all the time,